You're a product developer, and you've been given a project to develop a blended juice beverage. As you saw in the video, before you ever start your work on the bench, a number of things took place in both the concept development and the associated consumer focus groups that help determine parameters of the formulation of the juice that you're going to make. Let's look at three likely parameters. One of them is the percent juice in the blend. Out of the focus groups, what you learned is that consumers perceive a product with 100% juice as being natural and healthy. If it had a lesser percent of juice, they would think in terms of added sugars and find that not as appealing. So let's set one of those parameters in the spreadsheet, and the spreadsheet will help us keep track and simultaneously fulfill the several different parameters. Let's set the parameter for the percent juice at 100%. One of the sensory appeals of fruit juices is a blend between sweetness and sour. So there's a certain amount of sourness that's appealing. Too much, people won't like it. Too little, they won't. So what you determined is that an appropriate value for what's called titratable acidity, a measure of sourness, would be 0.6 grams of acid per 100 grams of juice. A third parameter, since you are a for-profit business, is to try to figure out how to make this juice and maximize the profit. There are certain costs that have already been established. What will it cost to process the juice? How much will each package cost? So these figures that you're seeing are based on a 1-gallon unit of juice. There's a certain amount of money that goes into both the storage and distribution as well as the marketing of the product. So before you even begin to think about the cost of your ingredients, you've spent nearly $3 to produce this gallon of juice. From comparative market studies, you realize that you can probably sell the juice for close to $5. So how can you achieve a profit keeping your ingredient cost below $2 so that the company makes money on each unit sold? In a sense, this is a mathematical problem. You're trying to come up with a solution effectively to simultaneous equations. You have a constraint in the percent juice, you have a constraint in the titratable acidity, and finally you're trying to maximize the value of total profit. In the algebra that you learned in high school, you could have actually written down three separate equations here and solved those. Well, these equations are a little more complicated because each equation has a number of contributing factors in it. So rather than do an algebraic solution, we're going to end up doing something called an iterative solution, and we'll come back to that once we get all the parameters put into our spreadsheet. The way we're going to approach this is we're going to put values for the three component juices, raspberry, cranberry, and apple, into this column of the spreadsheet. And we can play with those values to try to come up with an ideal solution for the formulation of the beverage. So if we want the sum of that to add up to 100, what we're going to need to do is put in a formula here. So over here in column E, we'll replace this fixed number, and instead we will make it the total of all of our juices. So in Excel, the way you do that is you open a formula by typing the equals sign, and then open a parenthesis, locate yourself in the first cell of interest of what you want to total, click and hold the left mouse button and drag down, release the mouse button, and close the parenthesis, and then hit the Enter key. So now as we begin to put numbers in here, it will sum to give us the desired. Uh-oh, got a problem. Need to put one more thing in this to tell it that you want to sum those values. So we're going to type the word sum, that's a function within the Excel spreadsheet, right in front of the parenthesis. Your procurement department has already looked into sources for these juices that you'll use in your beverage. And you've actually acquired some samples and determined a key composition of the sample. You've measured something called titratable acidity. That's actually an experiment you will do in class later as you work your way through this program. So it turns out that, not surprisingly, different fruits have different amounts of acid. Apple tends to be the least acid of many of the fruits, while cranberry is at the high end and raspberry is somewhat intermediate. So to figure out how much each component juice is going to contribute to the acidity of your blended product, we're going to need to do a multiplication to get that component contribution. So what we'll do is we'll say, in column C, we're going to refer to the amount of raspberry that we specified for our formula. And then we're going to multiply that by the titratable acidity of raspberry juice, and so that will give us the partial contribution of raspberry to the total acidity of the blended beverage. So to do that, we're going to say equals, and then we will take the percent that we've specified in the juice, enter, and now we will multiply the percent in the juice times the titratable acidity of pure raspberry juice, enter that formula, and now we have a partial contribution. Now there's one problem here. We're using percents here, but what we really want is proportions. And so to convert that, let's divide this by 100. We're going to do the same thing here for cranberry. So again, I will click in column C, type an equals sign, and then click on the amount of cranberry that we're specifying in the formula. Enter that. And then again, I'll do the same multiplication to get the partial contribution of cranberry. So percent in the blend times the titratable acidity of pure cranberry juice equals the cranberry contribution. But again, we need to convert that to proportion rather than percent. Done. Now, rather than having to type this formula out each time, wouldn't it be nice if we could just copy a formula? And we can, because as we move down this column and this column, the references ultimately are to the formula that we specified above. So let's go back to our raspberry. I'm going to temporarily eliminate the cranberry value. I'm going to go back to the raspberry and say, this is what's called a relative reference. If I were to take this one and copy it, and there's several ways you can copy. One is to grab the corner. See where it's thickened a little bit in the corner here? You can grab this corner and just click and hold your left mouse button and drag down, and it will copy that formula, but as it does, I've moved down a row, and so the reference to row 2 now becomes a reference to row 3. If I do that again, you would guess that the reference would be to E4, and it is. Similarly here, we can copy the formula down. Remember, all I want to do is multiply the percent in the blend by the titratable acidity, and each time I move down a row, I want to update that to reflect the figures in that row. So I'm going to drag this down through both of these, and now that's done. Remember, 0.6 titratable acidity is our target. So let's take this out. We have the target over here. What we need to do is sum these values and see if in fact we've achieved the target. So once again, equals, sum, drag through. So again, I'm clicking the left mouse button, holding, dragging through the 3 cells I want to sum, closing the parenthesis, pressing the enter key, and it turns out we're pretty close. The next step is to investigate the cost of our formula. So once again, we need to consistently refer to the same amounts that we've decided up here in our formulation block. So here we're going to refer to the percent raspberry, and then I'm going to copy that, updating the rows, and once again we have 10, 15, and 75 as we specified up above. Okay. Now here we want to find the component cost for each of the three juices, and to get that we take the percent in the blend, multiply it by the cost per gallon of juice concentrate, and we will adjust that to a proportional basis by dividing by 100. So what we could do is just utilize that formula that we worked with before. It's always nice when you can copy things and not have to type in the formulas individually. Obviously, you're less prone to make a mistake. But did we just make a mistake? Does this make sense? Anytime you're working with a formulation and doing calculations in Excel, you need to stop and think, is the result that I'm getting reasonable? If we multiply 10 times 7, that's about 70. But then we're going to divide by 100. And so shouldn't our result be roughly 0.7 rather than 0.09? What we've done here is we've just referred to the result in this cell. We haven't actually repeated the formula from that cell. So we're going to have to get rid of that. Let's enter our formula, multiplying the percent in the blend by the cost, dividing by 100 to change percent to proportion, and there's a number that reflects the cost of the raspberry juice in the formula. Now we can do some copying. We can copy here and drag down to get the component costs of each of the juices. Notice the very different value of these juices in the marketplace. These are the wholesale prices that a juice producer might pay. And raspberry and cranberry are both pretty high value juices, where apple, especially with the entry of large apple production from China that occurred roughly 20 years ago, brought the price of apple juice that you can buy internationally to a very affordable amount. Remember, our goal here is not a specific value, it's to maximize the profit by minimizing the cost of the juice ingredients while still fulfilling our required value of 100% juice and 0.6 grams per 100 mils titratable acidity. So we want to minimize juice cost. Let's sum that cost here. Rather than refer to this formula above, what we could do is copy it, although if we copied it we would also copy the background color. So in this case I'm not going to copy between blocks. Instead, what I will do is type in the formula, which is just a simple sum of these three component juice costs. Do we want to make this juice? It's going to cost us $2.19 for our ingredients. So let's put that information into our bottom line calculation here, our profit and loss calculation. So in this case, I do want to refer to the result of this calculation, so I'll just say equals, and then I'll click on that cell and click enter. So every gallon of this we produce and sell, we're going to lose 18 cents. We're also calculating a profit margin. That's a common calculation that's done in the business world. So what we're doing here is we're taking the profit and we're dividing that by the total cost of production to determine a margin. And in this case, our margin is negative. We're expressing this as a percent. So this is a profit margin percent. We've done quite a bit of work in this spreadsheet now. It's probably a good time to save it so that we don't lose any of these calculations if something strange happens. So I'm going to go ahead and click Save. And then think about where to go next. Somehow we have to lower the cost of these ingredients to bring ourselves into a profitable situation, but we still have to satisfy all of these parameters. We were a little bit low on the titratable acidity, so somehow we also have to boost the titratable acidity up to 0.6. And if you look at the titratable acidity of the juices, the higher acid juices, raspberry and cranberry, are also the more expensive juices. So it looks like it's going to be a little bit complicated to simultaneously satisfy all of these parameters. Let's play around with some numbers and see what we can do. Cranberry is high acid, but it's a little bit less expensive than raspberry. So let's see if we can drop the amount of raspberry juice, increase the amount of cranberry juice so that we still have a percent juice that adds to 100. Two things happen, and notice how the spreadsheet automatically updated because of the formulas that we put into it. Our titratable acidity now slightly exceeds our target value, and we dropped our component cost from $2.19 a gallon to $2.14. Seems like we're headed in the right direction. Let's make another change. Let's drop just a little bit of the cranberry out, replace that with a little bit of the apple. We still total 100. We've dropped 5 cents more off of our cost, and we've gotten a little bit closer to our targeted value for titratable acidity. So we're clearly headed in the right direction, and the process that we're using is called iteration. Another way to say that is guess and check. But it's a somewhat educated guess, thinking about the contribution of each of these blocks to the overall formulation. Doing this manually could take a while. Fortunately, the spreadsheet has a utility that will do many guess and checks or iterative solutions for us in a matter of just a couple of seconds. Let's unleash that utility now and finish off our design process. The utility in Excel for making iterative solutions to multiple equations is something called Solver. And depending on how much you've worked with Excel before and the particular installation that you're using, Solver may or may not already be loaded. If it's loaded, you will find it in the Data menu, and it would be in a group called Analysis. Since I don't see that group here, I'm going to go to Excel Help, type in Solver, and it gives me directions about how to load the Solver add-in to this particular installation of Excel. So I'm going to need to go to the File tab, choose Options, Add-ins, and then Manage them. Click Go to get that started. And then within the add-ins available, I'll select the Solver add-in, click OK. And then it will show up in the Analysis group of the Data tab. So let's go do that. File menu, Options, Add-ins, Solver add-in, click Go, select Solver, click OK, and now the Analysis group appears within the Data tab, and here is Solver. Let's open Solver and see how we work with it. So, what's the objective we're trying to achieve? It's right here. We're trying to minimize the juice ingredient cost. So we're going to set our objective by referring to our total cost. So we enter that cell, press enter, and we want to set that to the minimum value we can achieve. We're going to do that by changing the formulation of the juice, by changing the component raspberry, cranberry, and apple amounts. So we'll come down here and we'll select those cells, and where we're specifying those is up here in column E in the yellow block. Enter that. Do we have some constraints? Well, of course we do. We want our titratable acidity to be 0.6, and we need the total of the component juices to be 100, so we need to put that in. So we're going to add a constraint. We want total juice to equal 100. Let's add another. We want our titratable acidity to equal 0.6. Okay, we have both of the constraints in now. At this point, we should be ready to solve. We'll click Solve and see what happens. I'm going to pull this out of the way so we can see what the solver solution is. So, it manipulated the cranberry, apple, and raspberry amounts in such a way that it achieved 100% juice, 0.6 titratable acidity, so we've achieved both of those targets, and it reduced the component cost of our juices to $1.84, brought our total cost of production down to $4.79, gave us a profit of 17 cents per each gallon unit sold, or about a 3.5% profit margin. In the food business, that would be a pretty good return. However, we have a problem. I hadn't stated this explicitly, but a reason that raspberry was listed first here is because we want to call the juice cranberry raspberry. And if you don't put any raspberry juice in it, you can't legally do that. So, interestingly enough, you can call it cranberry raspberry with a very small amount of cranberry juice in it. Even as little as 1% would be allowed by the FDA, and you can still call it cranberry raspberry. So we're going to have to put at least a little bit of raspberry juice in there so that our product is not misbranded. So we're not going to keep the solver solution. We're going to go back into solver and add one more constraint. We need the raspberry juice amount to be at least 1%. So we're going to refer to the cell where we specify that amount, and we're going to say it has to be greater than or equal to 1. Click OK. Solve again. So here's our revised solution. We did get our 1% raspberry juice in there. Cranberry and apple have been adjusted accordingly so that we still satisfy 100% juice and 0.6 titratable acidity, and it raised the cost per unit by about 5 cents. Our profit margin dropped a little bit, but we now have a juice that is in legal compliance. It's in technical compliance with the specifications of our formulation, and we can still produce and sell it for a profit. So Solver was able to do for us something that we would have had to spend some additional time doing the guess and check method. And by establishing targets and simultaneously satisfying those by doing a mathematical approach of solving simultaneous equations through iteration, we have done the calculation work of our formulation process. Now we're ready to actually mix the juice and go to bench trials. Your assignment for use of Excel to assist with food formulation will be to use the template that I have placed on Canvas. And the template has some formulas already specified, and some of these parameters will be in it, just like the examples that I've just gone through. It will be a different juice blend with different required values for these parameters. And so you will need to do a couple of things. You will need to enter in the blend amounts and do the appropriate multiplications to fill in the titratable acidity, component cost, and so on. And then you will need to perhaps load and then run solver in whichever Excel you're working in to come up with a best solution that satisfies the two required values and at the same time minimizes the cost of ingredients and maximizes the profit for the juice. When you've completed those calculations, simply submit your spreadsheet to the assignment in Canvas, and then you're done.